Hi, welcome back to my channel pibyme Maths. This is Devan. Here we are looking at October-November 2019 Pure Math 1 paper. In the previous video, we have completed question number 1 to 6. Let's look at question number 7. We have a parabola given. The point P lies on parabola. It says figure shows part of the curve with this equation 2x squared plus 5 and point lies on this curve. Find the gradient of the tangent at P. So you need to differentiate it. You will get 4x. So replace x by the x coordinate. So when you sub in x is equal to 2, dy over dx is equal to 4 times 2, 8. Therefore, the gradient at P is 8. Part B now. Q with the x coordinate 2 plus h also lies on the curve. Find the gradient of PQ. So the x coordinate of Q is 2 plus h. We need the y coordinate. Submit this into the function 2x squared plus 5. So when you expand it, you are going to get 4 plus 4h plus h squared plus 5. So the y coordinate is going to be 2h squared, 8h, 2 4s are 8 plus 5 is 13. So the point Q is 2 plus h, 2h squared plus 8h plus 13. We know P, the point P is 2, 13. So use the formula for the gradient. y2 minus y1, 2h squared plus 8h plus 13 minus 13 divided by 2 plus h minus 2. You can cancel 13 and 2. Take h as a common factor from the numerator. You will get 2h plus 8 divided by h. You cancel h. Therefore, it's 2h plus 8. That's all. The part C. To explain part C, I have copied the graph here. Explain briefly the relationship between part B and part A. The answer to part B. In part A, we got the gradient of the tangent as 8 at P. We got the gradient of PQ as 8 plus 2h in part B, right? So what is the relation between these two? Okay, now listen to me carefully. Here the x coordinate of P is 2. Now let's say the point Q is here. The x coordinate is 2 plus h and some y coordinate, right? So this x coordinate is 2 plus h. That means that this distance is h, right? The distance between the x coordinate of P and x coordinate of Q is h. What will happen when we move the point Q along the curve closer to P? Let's say when we move the point here, the x coordinate will be here, right? So the h becomes smaller. That means the distance between these two is the h, right? The h becomes smaller. So as you move this point closer and closer to P, the h is become smaller and smaller and smaller. So what will happen when h becomes 0? In the point, okay, the y coordinate is basically 2h squared plus 8h plus 13. When you replace h by 0, you will get 2, 13, which is same as point P. What does that mean? When h becomes 0, this point will be on top of P, which is the same point actually. Q becomes P, right? And then look at the slope. When you put h as 0, the slopes are same, right? So we need to explain that actually when h tends to 0, the gradient of PQ tends to 8, which is equal to gradient of tangent at P. right? Both the slopes will be the same. If you want me to explain this graphically, okay, let's say the point P is here. We have point P here, Q here, right? If you take tangent at point Q, this is a tangent, right? When you move the point closer to P, let's say we move the point here, now the tangent is this. So as you move closer and closer, when the point Q sits on top of P, that means when it merges with P, that means Q becomes P, the tangent will be the same tangent at P. This tangent. So the slope of this orange line, the orange line becomes the blue line now, so the slope will be 8. So this is what you need to write to get 1 mark. Question number 8 now. Solve using algebra this equation and write the answer in this format. We have x minus 6x power half plus 4 is 0. I'm going to take x power half as p. So p square is just x. Sub it into the equation so it can be reduced to a quadratic, right? 6p plus 4 is 0. So p is minus b plus or minus root of b square minus 4ac over 2a. And then use the calculator to get the answer. 1 minus 6, 4. 3 plus root 5, p is equal to 3 plus root 5, p is equal to 3 minus root 5. We know p is x power half. X power half is 3 plus root 5. X power half is equal to 3 minus root 5. So x is equal to 3 plus root 5 whole square when you square both sides. But before you square both sides, make sure both the numbers are positive. This number is negative. Let's find out. This is positive, we know. 3 minus root 5 is a positive number. If it's a negative number, don't just square it. You just need to write no solution. For negative number, you cannot square it actually. You need to write no solution. But in this case, it's a positive number. So you can square this. So if you ask me why for negative number I cannot square it, when you learn P3, Pure Math 3, there is a topic about functions actually. When you look at the function of square root of x, we will consider only this graph, not the bottom part. So this function has only positive values. So square root of 25 is positive 5. Otherwise it's not a function. So this won't have a negative solution actually. So x power half cannot be a negative number. So do not worry about it. If you see x power half is equal to a negative number or x square is equal to a negative number, you need to write it as no solution. In this case both are positive, so square it, you will get a square plus 2ab plus b square, square root of 5 whole square. A square minus 2ab plus b square. So you will get 14 plus 6 root 5, 14 minus 6 root 5. So the answer is in this format. Question number 9, we have this graph given. It's the graph sine x over 12 where x is measured in radian. M is the minimum point. State the period. Okay, you need to remember this. For sine x and cos x, the period of these two graphs are 360 degree or 2 pi radians. The period will not be affected if you apply translation. If you move the graph right, left, up or down, the period stays the same. And then even you multiply the function by some number, let's say 2 sine x minus 5 cos x, the period will not be affected. The graph still repeats itself in every 2 pi interval. But the moment you apply this translation, this transformation, that means along x-axis, that's when the period will be affected. Because think about it, this is a sine graph from 0 to 360. This is sine x, y is equal to sine x. The period is 2 pi, right? The moment you sketch this graph, sine 2x. You're going to divide the x coordinates by 2, so you will get this graph. Now the period is also divided by 2. The period is just pi now. So of all the transformations, when it comes to transformation stretching along x-axis, the period will be affected. So whatever you are going to do for the x coordinates, right, you need to do the same thing for the period also. So in this case, when x divided by 2, we are going to multiply all the x coordinates by 12. So you need to multiply the period also by 12. So the period is 2 pi times 12 is equal to 24 pi is the period. And then state the coordinates of m. M is this, okay. Always compare it with the basic sine graph. In basic sine graph, this is pi over 2, 2 pi over 2, 3 pi over 2. So it's 3 pi over 2, comma minus 1. That's for sine x. Now it's y is equal to sine x over 12. So you need to multiply this x coordinate by 2. So you can write it as 12 times 3 pi over 2, comma minus 1, which is 18 pi, comma minus 1. That's the coordinates of them. It's just a one mark question. You don't need to show this working. Here also you don't need to show this. Part C now, it's a 2-mark question. The smallest positive solution to the equation is alpha, as you can see from the figure. The smallest positive solution to this intersecting with the line y is equal to k, is alpha, right? That's the solution alpha. When they say sine x over 12 is equal to k, they are talking about point of intersection of these two. That's the smallest positive solution is alpha. Okay. Now the question says, find the negative solution of this equation that is closest to 0. I'm going to explain this by taking the graph. So I have taken the graph here. We know the positive solution is this. We need to find the negative solution. So I'm going to extend this graph on the negative side. Let's say this is the graph. And we will extend the line also, y is equal to k. This is the line y is equal to k. This is the smallest positive solution. They want you to find the smallest negative solution, not smallest negative solution that is closest to 0. So this is the one closest to 0, right? Okay, we need to know this x coordinate of this point. In the actual sine graph, this is pi over 2, this is pi. But we are talking about this sine graph, x over 12. So we need to multiply by 12. So this becomes 6 pi, this becomes 12 pi. And the point of intersection of the graph and the x-axis, right? From that point to this distance is alpha. So this distance is also alpha. So it has to be 12 pi minus alpha. Sorry, this is minus 6 minus 12 pi. So the answer for this one is minus 12 pi minus alpha. You don't need to show any work. I'm going to explain this by using trigonometric equations and the graph also. Now, for WI, find the smallest positive solution to this. There is one result actually. Sine pi over 2 minus theta is equal to cos theta. That's one of the result actually. Sine pi over 2 minus theta is cos theta. This is true for any angle. So you can write cos x over 12 as sine of pi over 2 minus x over 12. This is cos x over 12 or k, which is same as sine x over 12. So I'm going to equate it to sine x over 12. I'll straight away write it as sine x over 12. But for this, the solution is alpha, right? So instead of x over 12, I'm going to write it as alpha over 12. If these two are same, you can equate the angles. Pi over 12 minus x over 12 is equal to alpha over 12. Multiply throughout by 12. You get 6 pi minus x is equal to alpha. So x is 6 pi minus alpha. You don't need to show any working. You can straight away write 6 pi minus alpha. Now I will explain this using graph now. Graphs and transformation. We have a graph sine x over 12 here. And I'm going to take the line y is equal to k. This is the line y is equal to k, right? So in the actual sine x, this point, the maximum point is pi over 2. This point is pi. But this graph is sine x over 12. So you need to multiply everything by 12. So this becomes 6 pi. This becomes 12 pi, right? So this point will be, because this distance also 12, so this point will be 12 pi minus alpha. So far so good, right? Okay. How do we get cosine graph from this? Because cosine graph starts from here, right? So to get the cosine graph, you need to move this point to here, the y-intercept. If we have a function, if we move the graph to the left side a units, it's x plus a, right? That means you need to when you move to the left side, it's x plus a, but you're gonna subtract 6 pi units from all the x coordinates, right? Now, so what will happen to this point? This point was alpha comma k. It becomes alpha minus 6 pi comma k, right? When the black graph, when the given graph becomes cosine x, cosine graph, this point becomes this, because you need to subtract 6 pi units. But we know 6 pi is here, alpha is smaller than 6 pi. Alpha is between 6 pi, right? So this value is going to be negative because alpha is a smaller number than 6 pi. You are going to get a negative solution. What does that mean? This point will be moved here on the left hand side of negative, now y-axis. So to find the first positive solution, we need to take this and apply the transformation. So when you apply the transformation, you need to 12 pi minus alpha minus 6 pi comma k. That's going to be 6 pi minus alpha comma k. So the x coordinate is 6 pi minus alpha. That's not the possible explanation. So that's all here. You don't need to write any working, just write 6 pi minus alpha. Question number 10. We have a cubic graph given 2x plus 5x minus 3 whole square. Deduce the values for values of x for which f of x is less than or equal to 0. Okay, look at the graph here. This is a repeated root, so x is equal to 3. That's when the graph touches x-axis. From here, the other root is minus 5 over 2, right? The question says f of x is less than or equal to 0. That means they're talking about the graph that goes below the x-axis, and the corresponding values of x are the solution. So x is less than or equal to minus 5 over 2. Is that the only solution? It's a only solution if they say just less than. You can just write this. But there is an equal sign. So you need to check from the graph where the f of x is 0. F of x becomes 0 here, right? That's the x-intercept. So x is equal to 3. You need to write both these solutions, otherwise you will lose them all. Part B, they want you to expand and write it in this form. So the function is 2x plus 5 times x minus 3 whole square. That's basically expand x minus 3 whole square. It's x square minus 6x plus 9. Open the bracket, take 2x and multiply everything. 2x cubed minus 12x square plus 18x. Take 5 and multiply everything, minus 30x plus 45. So f of x is, simplify the like terms, 2x cubed minus 12 plus 18 is 6. 6 minus 30 is minus 27x. Oh, sorry. Why I'm simplifying x and x square? Minus 12 and 5 is minus 7x square. And then 18 minus 30 is minus 12x plus 45. That's all. You don't have to write A, B, C, D separately. Just write this. Part C now. Hence or otherwise, find the coordinates of P. P is the place where the curve crosses y-axis. So you need to replace x by 0. So you will straight away get 45. So you can just write P of 0, 45. Find the gradient of the curve at P. We have f of x, 2x cubed minus 7x square minus 12x plus 45. Differentiate it first. You will get 6x square minus 14x minus 12. And then replace x by the x coordinate 0. You will get minus 2. Therefore, gradient is equal to minus 12. Part D now. The curve with the equation f of x is translated 2 units to the positive direction. If a function is translated to the positive direction 2 units, the new function will be f of x minus 2. Don't think it's f of x plus 2. Of course, we add 2 to the x coordinate, but when you write the function, it's f of x minus 2. That's g of x. We know f of x as 2x plus 5 times x minus 3 whole square. G of x is f of x minus 2. You need to replace x by x minus 2. So 2 times x minus 2 plus 5, x minus 2 minus 3 whole square. That's going to be 2x minus 4 plus 5. And then x minus 5 whole square. Hence find the y-intercept of g of x. So when you replace x by 0, the y is, this is 0, this is 0. So 1 times minus 5 whole square is 25. That's the answer for II. Question 11. Find the equation of the tangent. Okay, we have the slope at P already and the P. So we can straight away write y minus y1 is equal to slope times x minus x1. They want the answer in this format. Y is equal to mx plus c. So y is equal to 5x minus 20 plus 32 over 3. So 5x, 60 minus 60 plus 32 is minus 28 over 3. That's all. Just a 2-mark question. Part B, it's a 8-mark question. Okay. We are going to take f double dash of x first. 4 over root x. So f double dash of x is, I can write it as 4x power minus half minus 3. When you integrate it, it becomes f single dash of f dash of x is equal to integral 4x power minus half minus 3 dx. So it's 4x power minus half plus 1 is positive half by positive half minus 3x plus c. So f dash of x is 4 times half is 8x power half minus 3x plus c. Now we need to find this c and sub in here and integrate again to find f of x. That's when we need to use this condition. F dash of x is equal to 5 at p. At p means the x coordinate of p is 4, f dash of x is 5. So we need to write x is equal to 4, f dash of x is equal to 5. So replace f dash of x by 5, x by 4. 3 times 4 plus c. So c is 3 4s are 12, comes here 17. And then 8 2s are 16, comes here, c is 1. So f dash of x is equal to 8x power half minus 3x plus 1. Now we need to integrate this again. We will get another c, so I'm going to keep it as c1, or you can use other letter also. And next time when I integrate, I'm going to put it as c2. So when I integrate it, it becomes f of x is equal to integral 8x power half minus 3x plus 1 dx. So before I integrate it, let me explain something here. The condition given was f dash of x is equal to 5 at p, right? There are several different ways they can give the same condition. They might give you this way: f dash of 4 is 5, or the gradient at p is 5. So you need to know x is equal to the x coordinate of p, f dash of x is 5. Or they can simply say f dash of x at p, f dash of x is equal to 5 when x is equal to 4. These are all different ways they can give the same condition. Okay, anyway, I'm going to integrate this 8x power 3 over 2 half plus 1 by half plus 1, 3x square over 2 plus x plus c2. So f of x is 16 over 3 x power 3 over 2, 3 over 2 x square plus x plus c2. Now we need to use the condition. We know the point lies on the curve, so we are going to use the point p of 4 comma 32 over 3. So x is 4, f of x is 32 over 3. So 32 over 3 is 16 over 3 times 4 power 3 over 2, 3 over 2 4 square plus 4 plus c2. Let's calculate this carefully. 32 over 3. The first term comes here minus 16 over 3 times 4 power 3 over 2, which is 2 square power 3 over 2, which is 2 cube is 8. If you don't want to do that, just put it as 4 power 3 over 2. And the next term minus comes to the left side, becomes plus 3 over 2 times 4 square 16 plus 4 comes here minus 4. You get minus 12. C2 is equal to minus 12. So don't stop right here. You need to rewrite the function again at the end, otherwise you will lose a mark. F of x is equal to, write this function with the C2 value, 16 over 3 x power 3 over 2 minus 3 over 2 x square plus x minus 12. That's the required function.